Hello everyone, welcome to the next lecture on the probability and statistics. Today we will discuss about the factorial design. It is one of the most important topics in the testing of hypothesis. Myself, Dr. Garg, working in the School of Mathematics, Thapar Institute. So what we have discussed in the last class is that is a two-factor factorial experiment which is available on my YouTube channel, Dr. Harish Garg. This lecture is the extension of this two-factor factorial experiment. So you must have to watch this lecture before watching this lecture is there. What is that? If you have the two factors a and b, which is again divided into the two levels, low and high, and some observations are there, how you can solve that? This is called as the two-factor factorial experiment. That is our previous lecture. Now in general, if instead of the two factors, that is a and b, if you have more than two factors a, b, c, d and so on, then how you can solve such kind of the problem? That's why we will call as the 2k. So that is, if you have the k factors and each of the two levels are there, like these are my two factors and each of the two levels, but now instead of the 2, if I consider as a k factor each of the two levels. So what are the kinds of the levels? It may be of the high and low, that is of the qualitative form, or otherwise it may be of the quantitative forms like pressure, temperature, this is a temperature, time and so on. So if you have the k factor, each of the two levels are there. If I say this is my factor a, this is b, c and so on, this is of the two levels, high and low, high and low, high and low. So how many pairs are there? That is of the 2 raised to power k, and the corresponding factorial design is called as the 2 raised to power k factorial design. If you closely look about that, what is the value of the k in this case is 2. So it means 2 raised to power 2 factorial design is here. How many combinations are there? You can see there are the 4 pairs are there. So we write these 4 pairs, that is two factors a and b, that is one is the low, second is the high, and second is the high, and third one is the low are there, corresponding to factor a and the b are there. Similarly, if you have the 3 design, then we call as the low, high, b factor is a low, high, c factor is the low, high are there. We will generally denote the factors of the high and low with the sign of the positive and the negative are there. It means this is my negative, high is my positive, this is my negative, this is my positive and so on. These signs are called as the geometric notation of the factorial design. Like here, this is a negative, this is negative, high is positive and so on. And here it is a 2 raised to power 3 designs and so on. If you closely look about these two pictures, if you see that there are some symbols A, B, A, C, B and so on. What is the meaning of the small A, B, C are there? So for that we will define some notations is there. That is called as the ZS notation. Whenever we will use the capital letters, we will call as the factors. Whenever we will define the small a, b, c, we will call as the total of all the combinations. What is the meaning of that total combination is, if I say here, then these are my two factors a and b. Either a is my low, b is my high. This is, what is the meaning of the one? Is both are the negative. What is the meaning of here is a is my high. What is the value of the b? B is my low. So you can see a is my high, b is my low. So our main target is to analyze the impact of the A, analyze the impact of B, analyze the impact of the AB on the design of the experiments. Or you can say, what is the meaning of the both negative means? That is the both are the low level. One positive, one negative means A is at high level, B is at the low level, A as low level, B as high level and so on. And this table is called as the ZA table. But one of the most important feature, if you look about this table, one of the nice properties that if you look about the A, how many positives and how many negatives are there. So you can see there are the 2 positives and there are the 2 negatives. Also you can see in the B there are the 2 positives and the 2 negatives. So you can see each column has equal number of the positives and equal number of the negative signs are there. So you can see that A has the 2 positive and the 2 negative, similarly for B. Once you define A and B, then we can define the factors of the AB, which is nothing but the product of A and B. So you can see minus minus is plus, plus minus is minus and so on. Again you can see in this A there are the 2 positives and there are the 2 negatives are there. That is, they are always be equal. Now similarly you can see for the 2 raised to power 3 design. So now 2 raised to power 3 is 8. So you have the 8 designs. What is the meaning of this? Is C is negative, A is negative, B is negative. So you can see both, all are negative. Corresponding to A, this value, you can see this is my positive, this is my negative, and this is my negative. So these are here. Similarly, you can define as a AB interaction, AC interaction, and the BC are there. How you can find the value of the AB? You can multiply them A and B. AC is nothing but my A multiply C and so on. Again, you can see equal number of the positives and the negatives are there. And now the target is to have, you have to make the ANOVA table. That's a very simple. Now, if you have the 2 raised to power 2 designs, so how many pairs are? 4n are there. So the total degree of freedom is my 4n minus 1. Interaction degree are always be 1, 1 and 1. So can you find the degree of this? All of you know that the sum of them will be here. So this will be my 4n minus of 4, or you can say this is 4 times n minus 1 is there. After that, you have to find the sum of the squares. You can find the sum of the squares here. That's a very simple. How you can find the total sum of the squares? SS of the total. That's as we discuss in the ANOVA or the design of experiment is here. This G is called as the grand total. Capital N is called as the total number of the observations, which is nothing but my 2 raised to power 2 of n is there. That is a 4n are there. How you find the sum of the squares for the A, B and AB? We will call as the A square upon 4n. What is the A's? Bracket A, bracket B and call as the contrast are there. How you can find the value of the A, B and AB? We will discuss the 2 methods. The first method is based on here. You can define the value of the A corresponding to this. So look at that, the first number is negative. So you can multiply this value here. So this value is my minus of 1. You can multiply this value, it's a plus of A. This value is my minus of B, and this value is my plus of AB. Similarly, you can find the contraction of the B, that is a multiply of this by here. This is minus of 1 and so on. So you can see for the B, these two values are positive, so you can write as a B plus AB, other values are negative and so on. But here, this is 2 raised to power 2 is a very small number, so you can write a table here. But if you write as a 2 raised to power 4, how many are there? 16 observations are there. So it means this is a very difficult to write in such a way. So we always prefer to write this Zeta method. What is the meaning of that is, you have to firstly write the notations at here. What is the total of the A elements? You can write as a total of A, B and AB. Now in this case, what you can do is, you can simply write the addition of these elements are here. Addition of the second 2 elements are here. Once you writing the additions, then in this third column and the third values in here and here, you can subtract this value from here. You can subtract this value from here. You can write here. You can see subtract from here, subtract from here. Again, now do the same thing for here. You can add these 2 values. You can write here. You can add 2 values. You can write as here. After that, again, you can do the same thing. You can subtract this value. You can subtract these values from here. Now since we are working here is the 2 raised to power 2, that's why here is the k is my 2, that's why we need the 2 columns are there. If you are working on the 2 raised to power 3 design, so since it is a 3, so you have to make the third columns also. And if you closely look about that, what is that value? If you closely look about that, this value is nothing but my A. So I call as G is my grand total. This is my A, corresponding to the B, called as the B, corresponding to the AB, we call as the AB. Once you know the AB and AB, you can substitute the value here. You will get the values of these are there. Once you know all these values, you can easily find the values of this. That is the sum of this becomes equal to here. You can subtract them. After that, you can find the mean sum of the square. That is what is the value of the mean sum of the square is sum of the square divided by degree of freedom. That is this divided by here. And after that, F ratios are there. You can reject your null hypothesis. H0 is called as the null hypothesis whenever the F ratio value is greater than of the critical values are here. The last and important concept is how you can find the degree of freedom. Say your target is to find the value of F3, 2 at 0.05. The first value is always be the numerator. So you can see the numerator, look about the 3. Second factor is always be the denominator. So this is my 2. Level of significance is my 0.05 here. So what is the value corresponding to this is 19.16. Similarly, if you want to find the value of the 7, 3, 0.025, what is the value of this is 7 for the numerator, 3 for the denominator. Level of significance is my here. The corresponding value is my 14.62 are there. How you can find the main and interaction factor? What is the main and here? So if you look about that, the value of the A and B are called as the main factors, and if you product them, that is called as the AB is called as the interaction are there. How you find the value of the AB and A are there? That's very simple. The interaction of the A, main effect of the A is nothing but the contrast, that is we already discussed the previous two methods, divided by 2n are there. Similarly for the B, corresponding to B corresponding to A are there. Or you can say in general, whatever the contrast, you can say AB are there, you can divide it by 2 raised to power n k minus 1. Here we are working on that 2 raised to power 2, so the k is my 2. So that's why 2 raised to power 2 minus 1 is my 2n are there. Same, if you generalize them, you can find the sum of the squares, that is whatever the value of the A square divided by 2 raised to power k. So if it is here, then this, otherwise not. We will see discuss the 3 different kind of the examples, and these are most important are there. We will see the 3 different kind of the examples in here. Look at the first examples are there. So this is, say there are the 2 factors A and B, and each has the 2 levels, so it is called as the 2 raised to power 2 factorials. And this one factor is called as the decomposition, second is the here. Now what you can do is you have to firstly write in terms of the notation. So I can consider the short as a negative, long as the positive. Either you can consider short as a positive or here as a negative. We can consider this as a negative, this as a positive. Then your target is to firstly write these combinations are there. 1 A, B, A, B. What is the meaning of the one is? Both are negative. A means A is positive, B is negative, and so on. Now if you look about this value, this is my negative, this is my positive, 55 is considered as a negative, this is my positive. So what is the value of when both are negative? That is this orange color. So you can write this orange color at here. Now A is positive my here, B is negative, that is this values are, that's of the green color are there. So you can write this green color here. Similarly for this purple color, and for the last is brown color. Once you complete this table, then your target is to write this ANOVA table. That's a very simple task are there. Firstly, you can find the degree of freedom of this. How many observations are there? You can count them. Total are my 16. So the degree of freedom is my 15. This interaction factors A, B and always be 1. So what is the value of this, so that it comes 12 here. Now your target is to find the sum of these squares are there. How you can find the sum of these squares values? This is the formula we can use. So firstly I can try to write here, this is the xi square, these are my xi squares. So I will tell you this firstly, the first method, how you can find this value are here. The first method is my here, you can simply take them as of this square plus this square plus this square plus this square up to the last value is my here, you can see minus what is the G is my called as the grand total. How you can find the grand total is you can add all these 16 values and write here as the grand total. So if you, how you can find the grand total, if you find the total of this row wise and you can find the total of this is my here, and after the calculation you will get this number as 3.0672 is here. This is the first method. Otherwise what you can do is, if you see this calculation is very large, how you can do that, we will see the second method in the second example, which is much easier than of this. How you can find these values are there, you can find A, B and AB. That's very simple. We will discuss the 2 methods. Firstly you have to remember these formulas. What is the value of the A? That is the total of A is my this value. What is the AB is my this value, and so on. So you can see this is my A, this is my AB, this is my 1, this is my B. You can substitute, you can get here. Similarly for this and here you can substitute the values, you will get the required answers. But make sure that this method you have to remember these formulas. That's not an easy task. So that's why I always prefer to use this ZA method. What you can do is you have to firstly write the treatment 1, A, B and AB. You have to write the corresponding total. These values are written from here. This is the total of the 1, that is the sum of these elements. A is sum of these elements, and so on. Now what you can do is you can simply add these 2 values. This is value is obtained by addition of this and addition of this b. Now this value can be obtained by the subtraction of this value from here, subtraction of this value from here. Now can you do the same thing for here? You can add these two values here, you can add these values here, you will get these two values. Now you can subtract these two values and subtract these two values, you can get here. So this value is my grand total, this value is corresponding to A, this is my contrast A, this is B, and this is AB. And if you look about that, these values are same. Once you know the value of the A, B, and here, you can substitute this value in this formulas, you will get this here. So it means this value is nothing but my here. Now can you find this value? You can easily find that the sum of them will be my here. You can add them and subtract from this, you will get this number. Finally, you can, what is the mean sum of this square is SS divided by degree of freedom. You can divide them, you will get this. How you find the sum of F ratio is, you can use this divided by error. This is always be error here. Similarly, you can use this divided by error, you can write here and so on. Once you compute the F ratio, now you can think about the critical value. So 1, 12, always with the error. This is my here. Now compare all these values with the 4.75. For the A, this value is less than of this, so we can fail to reject it at 0. It means there is no impact. Look about the second value, which is greater than of 4.75, so H0 is rejected, so there is an impact on this. Similarly, look about the AB, since this number is less than of this, so there is no interaction between them. So this is the way you can solve this first example. Now look about the second example, which is again on the similar task are there. You can convert them firstly into this table. You can consider as 50 is negative, 75 is positive, this is high, low are there. So you can see when both are negative, the values are my here, 18 negative and positives here and so on. Once you will complete this value, then again your target is my here. How you can compute them? How many values are there? These are my 12, so the degree of freedom is 11. These values are always 1, so what are there? This is nothing but 8. How you compute the sum of these squares are there? You have to use this formula. Now we can compute the second methods are there. In the first method, what we have to do is you have to find this value as of like say 28 square plus 25 square plus 27 square plus so on up to this 29 square. But you can see in the previous example and in this example, a lot of the calculations are there. You need to find the 28 square. So in order to make the calculation easier, what you can do is, how you can make the calculation easier instead of this, you can subtract any number from this given observations. So let's say I can subtract, I can see that the smallest number is my 18, largest number is my 36. So I can choose any number in between them. So I can choose the 27. Either you can choose any of the number B. So I can subtract 27 from the each observation. 28 minus 27 is plus 1. 25 minus 27 is my minus 2 and so on. Now we can think on this table instead of here. Now you can see the observations we can compute from here is much easier. This is 1 square plus minus 2 square plus 0 square plus 9 square plus up to the plus 2 square minus what is the grand total is my here 6. So you can see 6 square divided by total element. Now you can see it is much easier. You can compute like of here. After the calculation you will get as 323 of here. Again you can compute them A, B and C. We will see that two methods are there. What you can do is you can write the first method here. What is the small ABC? These are my totals. You can find the total of this is my minus 1 here and so on. You can substitute this value here. You can see this is my A, this is my AB, this is my 1, this is my B. If you substitute this value, you will get these numbers are here. Again, I always prefer to recommend this ZA algorithm. What you can do is you have to draw this table, that is a treatment and the total are there. Now you can add them. This is 18. You can add them. This is my minus 12. You can subtract them. This is 20. You can subtract them. It's a 30. Again, you can add them 6. You can add them 50. You can subtract them minus 30. You can subtract them as of the 10 are there. Now once you will do, now you can see this is my grand total. This is my A, corresponding to A is A, corresponding to B is my B, this is my AB. Now you can see these values are same. Once you know the value of the A, B and AB, you can substitute this value in the sum of the squares. You will get this value as of 208.333, this is 75 and this is 8.333. Can you find this value easily? Yes, you can do that. You can easily subtract them. Now rest of the calculation is a simple calculation. You can simply divide them. You will get these answers. What are the critical values are there? You need the 1,8. So the critical values of this is 5.32. Compare this value with this 5.32. You can see the first number is greater than of this value. So H0 is rejected. So it means there is a significant effect of the factor A. Second number is also be greater than here. So there is a significant effect of the factor B. While the third number is less than of this, so it means there is no interaction effect of the temperature and the copper contents are there. Look at the another example are there, which is of the third kinds are there. Now in this case, again is a 2 raised to power 2. Here there are the two factors. Now you can see these are my negative. I can consider as a 25 positive. This is my negative, this is my positive. And here this is a block are there. So what you can say is, this is a 2 raised to power 2 experiment, but with the block experiments. What you can do is, again your targets to be here, but the thing is you have to add the elements as a block also. Once you will consider here, then firstly you have to write as a combinations like 1. Now instead of the AB, here is the N and S are there. Now you can complete this table. So corresponding to the block 1, the value of the 1 corresponding is 117. Corresponding to the value of the S is 106. This is the S. Corresponding to the NS is my 108 and so on. Similarly for the others. Now how you can find the values of the sum of the squares for the block, because rest of the part is similar. The new thing is block. I can firstly, again you can see the calculations is very lengthy, because if you take them as a 100, this square plus and so on up to the 105, the calculation becomes a very large, lengthy. So what you can do is you can subtract any number from here. So I can subtract the hundreds for the calculation becomes easier. So you can see instead of the 117, 17 square is much easier. Now we can find the sum of the block for here firstly. After that we can do it as a similar. This is the formula for the block. What is that? T is the total. So find the total of the first block here, total of the second block here and so on. These are my totals. So you can substitute this value. That is a 46 square. How many observations are there? 4. You can write like this way. Plus 65 square. How many observations are there? This is a 4 and so on. What is that? This is nothing but my G, grand totals. You can add them. This is G is my 37 divided by total observation 34. After the calculation you will get this number as of here. This number. Now how many blocks are there? There are the 6 blocks, so degree of freedom is my 5. How many observations are there? Total observation is my 24. So degree of freedom is my 23. This is my always 1. Sorry, this is my always be 1. 1, 1 and 1. So you can easily find the value of here are this one. Now rest of the calculations are similar. How you can find the totals are there? By using this observation. So that is 17 square. This is 17 square plus 20 square and so on. You will get as of this. So you can add them total. The total is my 37. After the calculation you will get this number as of here. How you find the value of the NS? You can find this one here. Now I always prefer this method, so you can write this as a total. If you add them, this is my total here, this is total, this is total, this is total. So corresponding to the one, what is the total of this? I can write like here. Now you can add them. This is minus 28. You can add them as a 65. Now you can subtract them. This is my minus 48. You can subtract them. It's a minus of 61 are there. Similarly, you can add them. You can add them and then you can subtract and so on. So what is that? This is nothing but my G. This is nothing but my A. This is my B. This is my AB. So you can now instead of the AB, now what is that? This is N and S are there. So this is my N, this is S and this is NS. You can substitute these values are here. You will get these numbers corresponding to here. Once you know all these 4 values, you can easily find the remaining part. You can add these values and subtract from here, you will get this 2. And this value are similar as that of the previous one. You can find this 4 numbers and here. What is the degree of freedom is? This is 1 and the error is my 15B. So you can know this number is my here. And you can see each of the observations are less than of this. So it means there is no significant effects on the here. So this is the way you can solve this 2 raised to power 2 design experiment problems. Remember, these 3 kinds of the problems are very crucial for you. We will see in the next class how you can solve the 2 raised to power 3 factorial design problem with same tricks. Till then, you can simply follow this link for finding the various videos. Best of luck, students. Happy learning.